Good morning, children. I hope you are all doing well. Today I am coming to a new topic in the fifth video. Whatever you have learnt all these classes like heat, temperature, differences between heat and temperature, so many activities related to that. Along with that, you have learnt specific heat capacity and their applications and the definitions of specific heat capacity and the method of mixtures. The last one in the last video is principle of method of mixtures. In that, what is the rule? Net heat loss is equal to net heat gain. And already I have mentioned that principle of method of mixtures is principle of calorimetry. Now I will discuss now what is calorimeter. Caloro means heat, meter means measure. It is an instrument to or a device to measure the heat in a chemical reaction or to measure the heat capacity. Here the heat capacity is nothing but specific heat capacity. Before going into our topic, let us discuss one of the activity. When you hold ice cubes in the palm, what you observe in the lapse of time, you observe that these ice cubes starts melting. What in general it happens, the heat of your body goes into the ice cube that you find the ice cubes are getting melted. In this situation, heat lost by your body is gained by ice cubes. So the ice starts melting. Here you have to assume that there is no heat lost or given to the surroundings. Then only you can tell that heat lost by your body is gained by ice cube. So ice cube starts melting. Here coming to the topic, here determination of specific heat of a solid. Here the one of the lab activity and a very important question in the board examination also. Aim of the activity to find the specific heat of a given solid. The materials required: calorimeter, thermometer, stirrer, water, steam heater, wooden box and lead shots. Calorimeter means here copper vessel, what you are seeing in the picture, along with the stirrer. Here wooden box is filled with some straw. Straw is which acts like an insulator, where you can place whole of the copper vessel along with the stirrer into the box. If you see, observe the lid, you have two slots are there. Through one slot you can keep the stirrer, or through other slot you can keep the thermometer also. Now coming to procedure, you have to measure the mass of the calorimeter. Mass of the calorimeter, copper vessel plus stirrer, that gives you M1. Now fill 1/3 of the volume of calorimeter with water and measure its temperature also. Mass of the calorimeter plus water gives you M2. If I want to calculate the mass of water, M2 minus M1, and T1 is the room temperature. Here calorimeter plus water will have the same temperature, that is assumed as T1. Take a few lead shots and place them in the hot water or a steam heater. But here you have to take a boiling water which is at 100 degrees Celsius. In that you place your strainer. In the strainer you have to place lead shots, because lead shots cannot be heated to 100 degrees Celsius directly. Let that lead shots temperature be T2. Now immediately after taking the heating the lead shots at T2 temperature, transfer the lead shots quickly into the calorimeter and stir it, so that you have to see there is no loss of heat. Now you wait for a while until the temperature settles to other temperature. Now measure the temperature of this contents. Let that be T3. Mass of the calorimeter along with the contents you have to measure. So measure M3. What is M3 here? Mass of the calorimeter along with the contents. this T3 temperature which is less than T2 but greater than T1. T2 is lead shorts temperature. T1 is water plus calorimeter temperature. Mass of the lead shorts M3 minus M2. And you have to assume that there is no loss of heat to the surroundings. One more thing you have to keep in the mind, entire net heat lost by the solid, here the lead shorts, is transferred to the calorimeter and water to reach some final temperature. This final temperature will be between T2 and T1. We have assumed already as T3. Now let the specific heat of a calorimeter be SC, specific heat of lead shorts be SL and water be SW. According to the method of mixtures, we know net heat lost by hot body is equal to net heat gained by cold body. Here, net heat lost by hot body means here lead shorts. Cold body, here two objects will come. One is calorimeter plus the other one is water. So, net heat lost by the solid is equal to net heat gained by the calorimeter plus heat gained by the water. In general, Q is equal to ms delta T. So that general equation we apply here to calculate heat lost by the solid. M3 minus M2 times of SL times of T2 minus T3, that is equal to heat gained by the calorimeter M1 SC times of T3 minus T1 plus heat gained by the water M2 minus M1 SW T3 minus T1. So, after observing careful calculations, I will assume SL is equal to M1SC plus M2 minus M1 SW times of T3 minus T1 by M3 minus M2 into T2 minus T3. Knowing the specific heats of calorimeter and water, we can calculate the specific heat of a solid. Here the solid is lead shorts. Now the topic is evaporation. When wet clothes dry, you will notice water in the clothes disappears. Similarly, when the floor of a room is washed with water, the water on the floor disappears within minutes and the floor becomes dry. Why this water on the floor disappear after some time? The phenomenon behind this is evaporation. Take a few drops of spirit in two petri dishes separately, one with lid, the other one is without lid. Keep one of the dishes containing spirit under a ceiling fan and switch on the fan. Keep another dish with its lid closed. Observe the quantity of the spirit in both the dishes after 5 minutes. The spirit in the dish that is kept under the ceiling fan disappears, whereas you will find some spirit left in the dish that is kept in the lidded dish. And behind this, the liquid molecules on the surface which have high energy directly converts into gas. Here gas is in the form of water vapor. The molecules of the spirit that is kept in the petri dish continuously move with random speeds in various directions. As a result, these molecules collide with other molecules. During this collision, they transfer energy to other molecules. When the molecules inside the liquid collide with molecules at the surface, the molecules at the surface acquire energy. They acquire energy, the force of attraction between the molecules will decrease, so they try to escape into the atmosphere. So, when a liquid is exposed to air, the molecules on the top surface keep on escaping from the surface till the entire liquid disappears into air. This process is evaporation. Whereas the energy of the molecules inside the liquid decreases and they slow down. That's the reason down part of the container will become cool. Is evaporation the process of escaping of molecules from the surface of a liquid at any temperature. Here the temperature should be below its boiling point is called evaporation, or a phase change from liquid to gas that occurs at the surface of the liquid. As I already told, drying of wet clothes, this conversion of water into vapor occurs less than 30. Similarly, the water spilled on a floor, the drying of the wet floor occurs at room temperature. In both the conditions, the evaporation or evaporating of this water occurs below its boiling point. So, we have to remember that evaporation occurs below its boiling point. Evaporation is nothing but a thermal separation or simply vaporization from the surface of a liquid below its boiling point. Evaporation is a surface phenomena, and during evaporation it is a cooling process. When we are doing a lot of work, we spend our energy mostly in the form of heat energy from the body. As a result, what happened? The temperature of our skin becomes higher and the water in the sweat glands starts evaporating. This evaporation cools the body. After coming from a games period, you try to sit under the fan in your classroom. You feel like cool. So evaporation is a cooling process. Rate of evaporation depends on 4 factors: surface area, temperature, humidity, wind speed. In the picture you have seen related to surface area, a stack of clothes as well as clothes spread and dried on a rope. In the stack of clothes, we have less surface area, while clothes on a rope will have more surface area. In this situation, surface area increases, evaporation increases. In short, you have to remember less surface area where less molecules escape as a gas, or more surface area, more molecules escape as a gas. In turn, evaporation increases with the surface area and vice versa. The picture related to temperature. On a sunny day, we see the clothes dry faster than the normal day. Why? Because increase in temperature, increase in its kinetic energy of the molecules. In turn, more surface molecules of the liquid will overcome the force of attraction and the molecules escape as a gas, while the molecules in the remaining liquid decrease in its kinetic energy, which causes cooling effect. So evaporation is directly proportional to its temperature. In the picture related to humidity, we observe that on a cloudy day, clothes will take more time to dry. As humidity is the amount of water vapor present in the atmosphere, rate of evaporation is closely related with humidity of the air. In other words, we have to remember that higher the vapor, lower is the rate of evaporation. So we feel more suffocated during the months of August and September due to more humidity, where there is decrease in rate of evaporation. The picture related to wind speed. On a windy day, we observe clothes dry faster than the normal day. With the increase of the wind speed, more molecules escape from the surface will be more. In turn, rate of evaporation is increased. So, whenever there is a combination of high temperature, very low humidity, strong wind, rate of evaporation will be very high. So, these are the factors which affects the rate of evaporation.